So lecture today, as I said, I'm going to talk about taxonomy terminology. So I feel that that's very helpful in trying to make sure that we're all on the same page when we're talking about stuff. One of the things that I've learned over the years is that there's a lot of confusion, a lot of ambiguity in the way that people talk about things from a security perspective. So I think I'm going to focus on just kind of talking about how we classify, characterize malware in this discussion here. And this should probably take all of this lecture today. That means that hopefully I won't spend a whole lot of time on this stuff next lecture, and we'll actually get into more kind of practical, in-class demonstration type of things. So, what? I feel it's important to talk about classification. A lot of you, if you do go into jobs that require malware analysis to be one of your functions, you need classification so you can come up with a way to describe what you're seeing to your coworkers and to maybe the community. But you're also going to be using it to do what I call risk scoring. There's a formal thing around that, but that's basically your weighting. I think this is more important because it's more serious. Therefore, we need to focus on this and ignore, object B, that type of thing. So, additionally, looking at malware samples that are, say, passing your desk on a regular basis or that are hitting your environment, that type of thing, I like to liken these types of liken the identification of these to, say, like a bird watcher may derive conclusions about the environment or about the climate or about changes in the environment, that type of thing, based upon, say, a year or two's worth of bird watching analysis. Likewise, like geologists, a lot of times we'll use landforms and they'll classify landforms, they'll classify stuff they see in the geology to try and draw some conclusion from there. For instance, trying to identify places where it would be good to drill an oil well versus not good, or places where you're likely to have a low-cost extraction of, say, natural gas versus not be able to. So likewise, malware that your team's seeing on a weekly basis, or in a particular week, or around particular times of years, or sometimes what you suddenly find yourselves not seeing anymore can be very informative. It means being able to take the, say, ecosystem of malware that you're seeing and classify what you can from it goes a long way to helping inform, say, your team and your employer or whatever about, say, broader malware threats, broader things that are happening in the, say, threat landscape. So I tend to talk about this in terms of malware taxonomy, and so that's a term that I kind of gave right there. It's just like taxonomy. If any of you have taken any of the biological science courses or something like that. So one of the reasons I am using a more kind of biological wording here is because that is a very common trend in cyber security and especially like malware analysis, stuff like that. I'm not sure how far that dates back to, but a lot of people treat it like that. So, so again, and I talked about this at the beginning of class, but I'm going to be really trying to talk to you in this regard from my personal experience. So this stuff right here that I put up here is kind of my observation, not really written down in any one of those books that I gave you. So. But I kind of broke up classification into three primary types of classification. So one of them is functional classification. I usually use this to describe the features, the functions that a piece of malware implements, and specifically malware typically being someone other than yourself trying to get code to run on your machine, right? So we can all agree on that definition is typically the purpose of malware in general. Running it on your machine typically has some end goals. And I listed a couple here that might be really common terms that you've seen in the news, so like backdoor or ransomware. Similar terms like that describe functional classification. They describe malware whose purpose is to implement some sort of end goal or end functional, objective. Objectives are a really good term for the benefit, or at least at the direction of the person who delivered the malware, the person who intruded on your system. So another method for classification is what I call familial or lineage classification. So this focuses on malware tools and who the authorship is, or maybe say where the shared code relationships are. So just like software, I'm sure that like all of you are familiar with, say, stackoverflow.com or anything like that. If you're trying to get something done very quickly at work, you're trying to overcome some hurdle with a framework and you just can't figure it out, documentation doesn't make sense. A lot of times you may go to, say, search up your problem on Stack Overflow or on Google. Stack Overflow or one of those similar things comes up, and there seems to be an answer there. It doesn't make any sense why that is the answer, why that solves the problem. But like any normal person, you grab the code from there, you try and adjust the variables and everything else to fit your particular use case, and voila, it seems to work. Perhaps with a bunch more research and everything like that, you can figure out exactly what was preventing your approach from working and allowing the implementation you found on the internet to work. However, you don't have that much time. A lot of times neither do, say, malware authors. So you will see that as well. That's another example of a component that I would put in as a familial or lineage classification. If it's public code on the internet, you've now adopted a piece of code that, say, a bunch of other people happen to adopt into their systems. That itself is a shared data point or a shared relationship between all those things. Likewise, you'll also see cases where a person who wrote a piece of malware at one point, and say a really small tool for doing denial of service attacks or something like that, which you may have read about. They don't do that and then go away. They're just like anyone else. They write something like that. It's a huge challenge for them to get it working correctly. Finally, they get it, they deliver it, then they want to move on to the next challenge. So the next challenge is maybe to write something that's a little bit more capable, a little bit more complex. So they might go and write a backdoor. Just like any other software author, they're going to borrow a whole bunch of code that they used for the first project when they start writing the second project. Again, that's another example of, say, malware authorship connections. Or you also see the same thing that you do in normal software, which is multiple releases, including version numbers and stuff like that. So, the Ghost malware, which has been around for a long time, or the Zeus malware is another example of one where they actually have release numbers just like Microsoft Windows has release numbers and things like that. So, but that type of thing is the shared authorship, shared family, shared code. That's another way to classify malware, and that's a very common way where if we happen to be following a particular, say, malware author, we're trying to make sure that we can defend against any malware that person has written. A lot of times if they decide to start from scratch, so to speak, with big air quotes, of course, they're not necessarily going to start from a blank slate. They'll start, say, writing a new backdoor or something like that, but they're going to have the same habit that most software authors do, which is to try and grab as much shared code as they can from a previous project or from their toolkit that seems to apply to it. And that's where benefit is to us in trying to identify those connections. So final one they'll say is behavioral. This one seems just on the outset to be related to functional, but one of the differences here that I say with behavioral classification is it's behaviors that the tool seems to exhibit. So not necessarily features or level of access that the program is giving to an author, but more behaviors or footprints or breadcrumbs that might be left behind on your system that might be common across different families. Some of you might be familiar with, and I'm going to get into it later, but malware samples that, like the one I showed you yesterday, it actually had that exe file that was embedded, or not yesterday, but Thursday, had that exe file that was embedded inside of the PDF object. So the PDF wants to write that to disk. It may give it a name so that it can run it, and it could give it a name that's called evil.exe. But if you see a program called evil.exe running on your system, then that evil.exe is going to be very obvious. Sometimes they might actually give it a name of a program that is common to run on Windows, like SVC host or something like that. A piece of malware that, say, decides to run itself as svchost.exe and use that name all the time, that's a behavior. It might be common. That's actually a very common behavior. And so that's an approach that can be attacked with like behavioral classification. Behaviors that are exhibited by malware, possibly for arbitrary reasons, rather than the actual access. That doesn't really have any bearing on what functionality is given to the attacker. It's primarily a behavior that's exhibited on your system when you run that piece of malware that might have to do with how it was configured, which might inform you of all sorts of different things as far as its history goes. So, but when I do a lot of malware analysis, when I'm writing reports, when I'm trying to explain things to people, these are usually the three, key kind of blocks of items that I try and learn about when I'm analyzing a malware sample so that I can describe it using these terms. Or I should say, so I can describe it in these ways. So, so this class, I'm going to spend this class's time talking about the functional classification, because I think that's the one that generally for most people, that's the one that you will read about a lot, is what level of access it's giving. That's also the one that informs, say, your team as to how threatening or how bad a piece of malware is, or possibly why somebody might be targeting your company with malware. So, and I'll also go through these. So I'll go through each one of these individually, and this is where I said that today's lecture is not going to be very deep and technical. We'll get to do a lot more of that stuff on Thursday. This one's more just kind of trying to set some common language and stuff like that, which I feel is very important, as it's there's a huge amount of ambiguity on a lot of these terms out there. So one thing I will say is that in my experience also, when analyzing these things, you typically don't run into a piece of malware that's like a single function thing. So most of the time when I'm analyzing tools, I can probably fit them into 2 or 3 of these categories up here. That's fine. That's typically expected. So I'd say typically something is not necessarily, a say monitor, but a lot of times it ends up being a backdoor, or I should say a tool that implements both backdoor and monitoring functionality. So that's typically how I like to try and describe things too, is using those types of terms. Is it's a tool, it's not a backdoor, it's not a worm, it's not a virus. It's a tool that implements, say, a subset of the functionality that I've listed up here. Another key thing that I'll add is that what I've listed up here is not all-encompassing. So I've definitely probably left stuff out. If I run into anything that I've left out that I feel ends up being important to class later on, I'll definitely introduce it then. But in going over things over the weekend and toward the end of last week, this was pretty much what I came up with after going through some of the resources that I had and also talking to some people. So we'll go through these. One that's really common, especially if you've taken like the information assurance course here, they actually use the book that has the fabled Trojan horse on the cover. So a lot of times this also will be abbreviated as just using the word Trojan. A lot of malware classification systems do this. It just makes it easier, single word, and everyone likes the kind of brevity approach to language. So how this usually works is it's usually used to classify a malware sample that employs some mechanism to conceal its true identity. And by concealing it, I mean it tries to pretend that it's something else. So in our example, for instance, the evil.pdf, even though it was named evil.pdf, it exhibited this behavior by concealing a PDF exploit and also a exe file. So when you send that PDF to somebody, you are conveying a document, you're conveying a carrier or a container, however you want to describe it, that's presenting itself as if it were a PDF. And that's what you're trying to convince the person that they are clicking on. You're hoping that the person doesn't think that they're receiving a PDF that contains an exe file as a backdoor. Other examples, I give a couple of other ones here, is malware embedded within a bundle. So say you're searching on the internet, and probably some of you have run into this where you're searching on the internet for a driver for your network card that works in Windows 10, or a driver for, say, a new USB device or something like that that works in Windows 10. You go search Google for it, and then you come up to all these sites that have random, say, domain names that you've never heard of that say that they have a driver for your piece of hardware. I'd say, number one, don't trust those sites. But number two, a really common approach is to try and convince you that you're downloading a exe file that may actually have the network driver you want, but also contains malware or something like that. So this is an example of something where if you're not downloading, say, the driver for your Intel wireless card directly from Intel's website, you might be downloading a version that someone else downloaded from Intel's website, then decided to package their own backdoor into, or their own adware or something like that. And then they managed to get on the top search results in Google somehow. Another example, which was probably one of the more fun ones that I had, because it led, so it was about 6 or 7 years ago now, led to some very interesting and spirited discussions at work when it was first seen, which was a demo music player. So it was a music player that popped up like, over here in the corner, like where the UC logo is, and it looked like an MP3 player, like one of those ones that has a really cool skin and everything on it. And it suggested that it was actually playing somebody's demo album from somewhere. So I can't remember exactly where. So when you run it in the sandbox and look at what's going on in the sandbox, typically I don't have the audio turned on in the sandbox or anything like that, so look at that. Ended up getting into a debate with someone as to whether or not it was malware or not, because it tried to reach out to the internet. After a while, we did determine that it was malware, but it looks like a totally legit app. So I'm downloading something. I'm expecting it to be an application that I'm installing on my system. So I click yes to all the boxes, because I'm a normal good user who clicks yes to all the boxes. And then it installs it, and then it seems to work fine. Turns out that it also would install a DLL that had a backdoor in it that would go and provided a number of features for stealing documents and credentials and things like that. So these are just a couple of examples of Trojan horses, but the idea here, and it's still prevalent today, is trying to, it's almost like building two pieces of software. You got to build the backdoor, and then you have to go and find something on the internet that you can kind of mold for your purposes, or maybe even, like in that music player example, write something from scratch that seems to look like it works more or less, and then convince the user to install that. So those are like really common. Those are really common approaches that are done today. Just say work-related Office documents, work-related PDFs, bank-related ones. You've probably seen a lot of the spam alerts that you'll get it'll say spam alert, but if you read the details, it goes into detail about what the attack was on your UC email. So UCIT is pretty good about notifying you of those things. Frequently on those, it's a Office document or a PDF that's carrying some sort of malware. So the next one, and this is really, in a lot of cases, the objective to a lot of malware that if you do go in to do this work in the future, where you'll end up spending a lot of your time. And the reason is that both backdoors and remote access tools, remote access tool is a backdoor. I separate them here mainly because I see them commonly separated in my experience. They provide that interactive access. So this is how, somebody gets this installed on your system, then they have the ability to navigate your files. This is what I installed on that Windows XP virtual machine after we exploited the Adobe Acrobat Reader 9.0 installation that was on there. It can give you varying levels of access and also give you varying levels of power to that access. So like the one that I installed, and I talk about it down here below, but that one that I installed gave really rudimentary access. It pretty much ran command.exe on the host, the Windows shell, and then it provided me a channel where I could interact with that process running on the host. So I could act as the user as if they were to have popped up an MS-DOS or Windows command shell window on their desktop, except it was hidden from the user. I've seen other backdoors that are a little bit more featureful, including ones that have some basic upload-download capability. So one thing that you'll probably gather when I was interacting with the system using that command line is if I have other files I want to get on the system, I need to figure out how to go in the user's Windows, how to go in the user's Windows folders and try and find another program that I can use to fetch stuff from the internet or something. My only channel to get new files on that user's computer is somehow to get their computer to pull it down from the internet and run it. There's other backdoors that have that interactive command line feature, also have some file transfer capability as well. So if I see something neat, I don't have to try and push it up to the internet. I can actually just pull it directly through that command line channel that I have. Another group of backdoors is called remote access tool. Those of you who've ever worked in like IT support and things like that might be familiar with, I can't remember, like VNC or remote desktop, those types of things. And then there's even more powerful, like TeamViewer is another good example as well. There's even more powerful remote access client server models out there. And there's a lot of really good ones written, and we'll go into a few of them too later on in the class. There's a lot of really good ones that are written for attackers as well. So two that you might have seen written about is I think Poison Ivy is one of them, and Dark Comet is another one that's really popular. They provide all sorts of functionality and typically have a really nice, efficient user interface to managing not just one intrusion, but multiple intrusions at the same time. So they'll give like a management console, or a management list, I should say, that allows you to select individual hosts of like 10 or maybe 100 or something like that you have the backdoor running on. And then also you can go and do the file transfer capabilities, have direct access to like the camera and the microphone and all that stuff, be able to manage the services that are running on the system, install, uninstall drivers, that type of stuff. So almost like a lot of them even give you basically a, should say an attacker side version of that computer manager that you have in Windows. So if you've ever used the, instead of the control panel, there's like that whole system manager or whatever that you can use. They'll have a version of that they can actually see on their system in, in one of those tools. So typically I relegate the term remote access tool for that. And it's all, honestly, a lot of those tools, were they not primarily focused for attack, there actually would be very efficient ways to, to manage a network of computers, because that's basically, at the end, that's what their goal is. It's to manage a large network of computers and to do it in a very stealthy, unintrusive way. So were it not for the fact that all antivirus programs identify them as malware, those tools would actually be really good for building an IT shop, unfortunately. So the next one I'll talk about is what I call downloaders. A lot of times you'll see this type of malware actually combined with another tool like a backdoor. A lot of times this type of malware will be what is delivered via a fish or something like that. So we did not use this one when I was doing that attack on Thursday. But this one ends up being, let me see how the best way to describe it. You deliver, say, the malware somehow, like we package it inside of that evil PDF. It runs on the user's system, then it reaches out to the internet, say to a website or to a secure channel somewhere. It pulls down another program or another file that then is whichever backdoor you wanted to install in the user's system. This has the nice effect of you being able to have a very small tool whose only functionality really is to fetch stuff from the internet. So behaviorally, that's a very difficult thing to classify against, because I know one of the really popular things or approaches to system installs today is to have a very lightweight system installer for like Java or for Acrobat Reader or for even the Windows Microsoft.NET framework, where you get a little tiny file for setup.exe, you run it, and then it goes on the internet and it pulls all the stuff it wants, all the stuff your system needs from Microsoft's content delivery site. So behaviorally, this is a good way for someone to get malware to your system that doesn't really look like it behaves like malware. So it's not really clear that it is malware. And then it can go and fetch a bigger program, a bigger backdoor, a bigger remote access tool, or whatever it happens to want to fetch from the internet, from some arbitrary site that's hard-coded in it. Preferably a site that, say, the attacker has a decent amount of control over, and sometimes even it might result in the same attack going to 100 people, and those 100 people's systems downloading different versions of a program, possibly based upon if the downloader determined what version of Windows they were running on their system, or even just because the attacker decides to host different malware over different times of the day on that same site. The big thing here is that it allows them to break up the attack into separate tools. That can help reduce the detectability, if they do it right, of their attack. It can also facilitate what I call surgical retooling. So in that case, if they screwed up the delivery, they can very easily go and make from scratch a completely different downloader tool, because that's a very simple set of Windows API calls to basically have a program that runs, downloads something, and then executes it, and then exits. That's a very simple sequence of steps to write. So if you want to rewrite that tool from scratch, it's not too difficult to do. So if you mess up the first attack, you can try successive attacks by retooling without having to rewrite the entire backdoor or come up with some way of how to conceal your backdoor from the user's defense. So another tool, which is very concept similar to that, is what I call a dropper. And this is basically one where when you get, say, a payload from an attacker, the dropper will then write another file to disk that's separate from the one that was received by the user, and then it will run that. So it's very similar to the downloader minus the network part. So it's like a downloader, but in this case, the thing that would have been downloaded is actually embedded within the file somehow. A good reason for this strategy is very practical. It's that on all of our processors today that are on most of our computers here, it's nearly impossible to run encrypted code. You generally have to decrypt your code to some sort of native machine readable format before you're able to point the instruction pointer at it and start executing stuff. You can make, say, encrypted code if you want. The only problem is it can become very complex and failure prone, and also it can become very slow, impacting, say, end user performance, and thus sacrificing the whole stealthy aspect that you want. So that's where I say a lot of times this approach is done for a very practical reason. It's because like a lot of these backdoors, if you do not want to, or I should say, if you as the attacker do not want to learn new attack tools, what may benefit you in trying to get past somebody's email defenses or something like that is to package an encrypted version of the backdoor inside of whatever you're sending to that user in email, so that their email defenses don't know how to decrypt it. And then the user pulls the thing down, the PDF, and opens it, and the PDF has malicious code within it that goes to decrypt that encrypted file and write it to disk. And there's a lot of different ways you can do it, especially in something like Java, or I should say in PDF, that supports, for one, JavaScript programming language in it. So and the reason it's called dropper is because it drops, say, an exe program. I use the term exe program here. It doesn't have to be an exe. It could be anything, really. So where I say like exe program and stuff, it doesn't have to be that. It could be anything. That's just a probably bad habit of mine. But you know, in the case of evil PDF, the one that I showed you, in addition to be considered a Trojan because it was something that was trying to get you to pretend, just like the Trojan horse thing, they're expecting it to be a gift, and it ended up containing an attack. This PDF that I got, that I was giving to the Windows XP user, they're expecting it to be maybe, you know, a menu or something like that of Chinese food. Actually happened to contain malware. So in that respect, it's a Trojan, but then it also is classified as a dropper because, say, rather than having code embedded within the PDF, it has to write that code to disk. So it actually ends up exhibiting some other behavior too, which is writing to disk the program that has the backdoor. And then it has to use Windows create process to run that exe program in order to set up the remote channel to connect to our Metasploit instance. So I don't know how many of you went back and rewatched that presentation when I was doing that attack with Metasploit, but you'll notice that as soon as the document opened up in Adobe Acrobat Reader, the remote channel didn't set up. It wasn't until later, after we clicked through some of the dialog boxes, that you actually had that connection. And that's because there's a sequence of actions that had to occur before that would occur, and one of those was writing the file to disk and then loading it up and executing it. So another common I have a misspelling there, apologies. Another common function that's implemented is what I call botnet. I would say this is very similar to backdoors, and in some cases is a feature implemented alongside backdoor functionality. But one of the important differences with this is that where a backdoor is supposed to be able to give somebody direct access, one-to-one access to, say, a compromised system so they can interact with it, you know, basically what they call hands-on keyboard. A botnet is typically set up, or I should say botnet functionality is implemented so that a number of systems, like 1,000 or 10,000 or 100,000 even, will all connect into a common control point. And the user will instruct all of them to do common action, or to do, say, single actions in parallel. So you could probably think that logistically, trying to navigate the directory structure of 1,000 systems in parallel, that would be very difficult to do, if not a very impractical approach. However, having 1,000 systems or 10,000 systems all try and download a large file from Microsoft's website at the same time. That is actually a very simple type of command that if you wanted to saturate all of Microsoft.com's bandwidth at one point, having a whole bunch of systems around the globe that you're controlling connect in to pull that down would actually be a common like botnet action. Another example, and that I'll just say is what they typically call distributed denial of service, which is you try and get an army of systems, like in the tens or hundreds of thousands, maybe a million systems now, to try and connect to a specific target and exhaust all of its resources. So a lot of people have used this against banks and stuff like that. I think most recently I can't remember, it was like in 2014 or something like that, I believe that some of the US-based banks were targeted by one of these in a what was thought to be a very politically motivated denial of service. Another common approach is, and we'll also get to some of this feature later, but another common approach is maybe using an army of machines like that and then distributing out a target list of 2 million emails that you need to send out among those 10,000 machines. So rather than having one machine send out 2 million emails from one origin point, you can distribute it across 10,000 machines, and that's a lot more difficult for somebody to plug holes in their firewall to prevent. And so it also allows you your attack to be much better anonymized too, which is why this is this can be very common. So. So the next one that I'll talk about is monitor. I kind of hinted at this earlier with the remote access tool description, but I do like to classify these as their own kind of a category of malware. I have seen them, especially as bandwidth has gone up, I have seen them become a lot more commonplace to use. And even it's been reported in the news and stuff like that that people have used them for either information, IP theft, or espionage rumors, all the way up to like extortion and things like that. So, one of the basically the idea is that getting a tool on your system that has the ability to use any of your system's inputs to stream whatever its data feed is back to the attacker. So a really common one is webcam. I think in one of the recent botnet takedowns that you might have read, they actually went through a whole bunch of the webcam pictures. So they didn't publish them, but they went through and they talked about all the webcam pictures that were being taken by people. To try and figure out who they were targeting and stuff like that. They were actually using that to sell access to other people. So you're using a botnet with monitoring capability to be able to sell, say, or ransom off whose systems they had access to different people. Obviously webcams are really common security concern, so much so that it's become very popular nowadays to see people wandering around with like Post-it note over the camera that they have. That's pretty much ubiquitous in all your systems nowadays. It's almost impossible to get a system that doesn't have a webcam or a microphone. So the less common one that people cover up, but equally as damaging as the microphone. And then there's desktop recording. That one's also really common. We've got a number of tools that can do that and do it in a very easy, or provide a very easy user interface to the attacker for managing that as well. Even have versions of it that can stop recording when the mouse isn't moving, and then as soon as it sees mouse movement or keyboard pressing or the user logs in, or even on some of the newer systems, they actually have like presence detection. It'll kick on the desktop recording so that it can save bandwidth. Doesn't look like doesn't look like there's a backdoor streaming data off of a rogue system in the middle of the night, but then when the user comes into work, suddenly it starts streaming data from the user system. However, that's very difficult to pin down to the attacker because the user naturally, when they come in the morning and throughout the day, they're constantly streaming data as well, especially if they like to, for instance, watch watch sports programs on during their workday, or even participate in a lot of work meetings and stuff like that through some sort of telepresence type of mechanism. So other kind of recording mechanisms I put up here too, password prompts. So there's tooling looking for anytime a dialog box pops up with the word password in it to just grab whatever the user enters. Streaming anything written to common data folders, just immediately identifying that and streaming it back to the attacker keyboard, so getting a copy of the keys that are being pressed on the keyboard, which naturally you're likely to pick up passwords out of that. I don't know if you've ever looked into it, but if I had somebody's all of someone's keyboard presses in a text file that they had done throughout an entire day, I could probably, with a high level of certainty, pick out which of the things that they've entered that day were the passwords, without the context of what the dialog box was asking for. So, so key logging is another really popular one too. That they'll stream off, and then web browser traffic. So making sure that all your traffic, gets saved and then streamed off somewhere, and then even just raw network traffic as well. So, just raw undecoded network traffic as well may be another common monitoring feature. So, but the big thing here is that it's it's functionality providing a constant stream to a data source that might be of use for information or for financial gain to the adversary. So I kind of hinted at this one earlier, and this is very I'd say very attack specific, but since unwanted email, I'll just use unwanted email to kind of categorize all of it. Since unwanted email is such a prevalent problem on the internet today, I figured I'd highlight it here because it alone is a functionality that is very commonly implemented in malware that is used, or I should say that is delivered to people's systems, and that's mailer functionality. So the reason why this is beneficial is because even delivering, say, bulk advertising, things trying to sell you medications that absolutely don't work, or things trying to get you to go and buy shirts, or things trying to get you to go on random dating sites and crap like that. Not even the ones that are advertised on TV, but a whole bunch of just ones that are complete scams. That stuff is so lucrative because in many countries, that stuff isn't even illegal. It even, sits on the, acceptable side of the law in the U.S. many times, even though it's a complete scam and it's just a gimmick for stealing your money from you. Because of that, because there's a lot of gullible people out there who are somehow put in front of computers, bulk advertising like that ends up being a very lucrative way if they can just get the word out. And so a common way for them to get the word out is to pay somebody to use, say, a large botnet or something like that to send out bulk advertising. Bulk malware phishing also for, say, financial theft and stuff like that, also a very lucrative thing. So you'll have a lot of these people who set up large networks of systems that they can use to send unsolicited emails from. One of the reasons why they need to have these huge arrays of systems, and I talked about it before in the botnet discussion, is anonymity. So number one, it makes it really difficult to tie it back to any one person or one entity. So for instance, in the advertising space, if you can't prove that somebody paid for the advertising to go out, then you can't exactly, even if you do catch the advertiser, you can't exactly tie them back to, you can't punish the company that was being advertised for. Likewise, if they can find a way to anonymize themselves, cause a whole bunch of other people's systems to send out the spam instead of their own server, then they can also escape any sort of investigation as long as they do it well. And many of them don't, but some of them do. One of the ways that they do achieve that is that if you can have like 10,000 people's systems all sending out a list of emails, say to a huge list of 2 million targets, then if any one or say 5 of those systems get categorized as a source of email spam by say UC's email filter, that's only a small percentage, like less than 1% of the total body of systems that are dedicated to this attack. So it becomes very difficult, for instance, for say any one company's email defense systems to keep up with, say, 10,000 systems every day sending out email, especially if those systems also happen to be used for legitimate purposes as well, and they just happen to have become, say, compromised by malware. So that's kind of what they're hedging on, is that they're sending malware from sources that, or advertising from sources that otherwise are typically doing legitimate things, even sending legitimate emails. And then it becomes something where it's a lot more difficult to defend against when you're getting a mix of mix of traffic from a source. So another thing too that I'll add in here is that some of you have taken like computer networking or have worked with some protocol stuff. So I'll just mention it here. SMTP is a really common protocol that's used for mail around the internet. Some of these backdoors that implement this functionality may use that protocol and just directly connect to, say, the target's email servers to send out email. Others may actually implement more complicated mechanisms, and rather than sending from that, they may actually just try to distribute email using a Gmail, a list of Gmail accounts, or even the Gmail account that, say, 90% of their targets have. Or I should say 90% of their compromised systems in their botnet have. So that's a big benefit to them because it makes it look like the victim is sending emails from their Gmail account. A lot of times Gmail accounts end up being considered more trustworthy than some random host on the UC network directly connecting to send an email to someone else at like a company or something like that. So another common functionality is what I call like scareware or adware. You'll see scareware, or you'll see it talked about a lot, but I try and define down exactly how the actual attack works. The goal here typically is to try and get money out of a user. And with a lot of these things, with most malware on the internet, the goal in the end is some sort of financial gain. So like the mailer, for example, that I described earlier, financial gain there is that there's this huge economy that's willing to pay people to go and send out all that spam that you see. So a lot of times people who are sending that stuff out, they aren't even the people who put the attack or put the malware together. They're just someone who's paid to send out bulk email. So in this case, what they're trying to do here with scareware or adware is either they're trying to scare the user into paying money to somebody to fix a perceived problem on the system, or maybe just trying to get the user to pay money for some service that the user thinks they're going to get. So a common approach, I have a picture of one right here, which is very common. Although you cannot see the URL up there, I think it has a domain name that has a few letters and then like 10 numbers in it, .com, which definitely doesn't look legitimate at all. You might receive an email and tells you to click on that, or very commonly, you may actually be visiting a news site, and this may pop up on one of the advertisements. I know that even me, I've got my phone here. Periodically, I'll be reading news articles that I've had somebody share on Facebook or something like that, and very commonly advertising spam will pop up telling me, oh, I need to go and install some sort of antivirus tool they want me to download on my Android phone. And I know it's bogus, but a lot of people don't. So that type of stuff is like what, in this case, fake antivirus or whatever. Please install this tool or else bad things are going to happen. This tool costs money, that type of thing. Other times, they may just annoy the system owner until a fee is paid to remove it. So you might keep having a pop-up. I know I've seen that one come up a lot, which is, the pop-up keeps coming, and then they have somebody pay to get rid of the pop-up, and the pop-up gets put to sleep for like 60 days or something, or 90 days. And then one day they come in and it's coming up again. And they have to call the number, or they go to some like really shady website or something like that and add their credit card information, and then they pay the fee. Or maybe they don't pay the fee. Maybe they just put their credit card information in the form thinking they paid the fee. And then it turns out that really their credit card information was stolen. So there's a whole bunch of different approaches to this, but the core thing here is it's really a social engineering attack. A lot of times it ends up being built into a tool, so it's something that somebody usually has to construct. So it's malware that has to be constructed. It's software, and the goal is really to try and get some sort of positive financial outcome for the whoever the adversary happens to be. So another one, this one's actually very interesting because I do not believe that any of the books that I mentioned at the beginning of the first lecture actually talk about this one, because it's really only become prevalent in the past 3 years or something. It's only really become something that anyone talks about in the past 2 years, and it's ransomware. Basically, how ransomware works is it's similar to the scareware, but it takes it a step further. So rather than being more or less benign but kind of annoying, this one actually, if the malware runs on your system, it goes into places where you typically store your more sensitive files. So like My Documents, your desktop. A lot of times it'll even go and crawl around if you have a removable drive that you plug into your system a lot. It'll go and crawl around that and try and lock everything up. What it ends up doing is it creates an encrypted archive using whatever encryption algorithm they decide to implement, and then a password that's known only to the adversary. And they'll encrypt all your data and put it in this archive, and then they'll delete all of the unencrypted versions of your data, the originals that are in that folder or on that system. Then you get a notice, and it might be dropped into that folder when you try and go looking for those files in the future, or it might even be popped up in a pop-up to you, or it might be it might replace the home page on your web browser with a page that describes what you need to do, and it tells you, please transfer X amount of money to this account, sometimes using Bitcoin, sometimes using other payment mechanisms, and you can have your data back. And usually, in American dollars, it ends up being maybe a few $100s, maybe up to $1,000 or something like that they want people to pay. But it's very common. It's becoming more and more prevalent, and a lot of the authors of this and a lot of the users, or a lot of the attackers that have been using it, have been getting more and more advanced in their use of it, and a lot more daring with it. One of the other things that it's been frequently associated with lately has been causing outages and things like that. And one of the big things with that is if you work in an environment where transferring files from one file share to another or across folders in your environment ends up putting them in places where operational parts of your, say, facility of your business work out of. If somebody starts to lock those things up and delete them, then you run into a situation where if files are copied from one place to another and they get locked up before they get transferred to the, to the destination, then whatever part of your business is reliant upon that destination, reliant upon files constantly making it there, basically gets stalled. And you might actually end up incurring an operational problem. And that's actually what happened recently, I think, at a hospital that was down in the southern U.S. somewhere. In a very famous recent news story.
Aren't these people worried about getting caught?
So some of them do.
Worry about it or get caught?
Some of them do get caught. So I know one of the big challenges to catching these people is that unless they're operating in, say, Europe or the U.S., really, it becomes very difficult because we don't necessarily have jurisdiction overseas in a lot of places. We do have like FBI operates overseas and stuff like that, and then also some of our Department of Defense agencies also operate overseas. There are some international policing organizations. The UN has some capability and stuff like that, but by and large, they're reliant upon people. They're reliant upon local law enforcement in various countries, which may be parts of Africa that are really emerging markets that don't, that if you want to put a business there, you rely upon private security. So because of that, it allows a lot of people to get away with doing this stuff. And honestly, I don't know how stiff the penalties are for a lot of this stuff if someone is caught overseas. So I don't know what exact punishments they face, whether it really outweighs, say, a lot of the benefits that they're getting from this if they dedicate their life to it for 10 or 20 years. I do know that there have been a number of really, high-level takedowns, and then a handful of operators that have been, say, extradited to the U.S. after they were caught during travel and stuff like that. I could actually go and probably find a couple examples of that for Thursday's lecture. But by and large, because a lot of them operate internationally, and the internet's a big global network, we typically try and attack it by seizing infrastructure. That's more frequently the case, is seizing infrastructure and then just dismantling the infrastructure and notifying all the victims. Less frequently, but it does happen. People do get caught, they get arrested, they get tried, they get put in jail or whatever. Who knows what happens if they're found, if they've been targeting people in other countries, and then those countries' agencies find them. So, but I would say that because this stuff is considered a very serious crime in the U.S. and a very serious crime in Europe, that's probably a good reason why we do not see a large amount of this type of activity originating from like those two regions. Is because there's a very strong police presence is policing this stuff, and the penalties are so high. So it's very difficult to get away with it if you're in the U.S. But it does happen from time to time. So another piece of malware, or I should say another malware function, I've got more misspellings, oh well. Another function that I've seen implement in malware is what I call information stealing functionality. It's generally, while some of the ones like the backdoors and remote access tools that I described to you earlier, they give you the ability to achieve these goals. A lot of times it's very common for somebody to implement what I would call information stealing functionality directly into malware. So for instance, this would be malware that's automatically configured to download your entire contacts lists, especially if it's to download your Outlook, your Thunderbird, your Firefox, your Jabber, your AOL Instant Messenger contacts list. Or browser cookies, history, saved credentials. So all of these things, all these pieces of data that are useful, pieces of personal information, they live in very well-defined locations on your system based upon which application stored them. And because of that, it's very easy for somebody to write a piece of software that goes and walks through that hierarchy to try and steal that information. So in many cases, they might actually send out malware that goes to a whole bunch of different people, runs once, collects all these things, transfers it, quits, and then disappears forever and never comes back unless you get rephished or something like that. It's a good way for them to maintain, again, to evade, say, law enforcement. If they don't have constant presence on your system and they're not constantly trying to make a connection, then the fact that 1 year ago they had stolen all your personal data and then they never touched it again, that's going to fly under the radar. That's going to be almost impossible for anybody to prove. That's one common approach that's done as well, especially when it comes to like OS passwords and key store data. I know some of you probably have like Macs and stuff like that, and so you're familiar with the like keychain tool that's in the Mac, and then some of you that are using Windows systems probably have like LastPass and stuff like that. So those are all like key store systems where you take all your private credentials, your private authentication mechanisms, and you shove them in this one tool. But it also means that if anybody manages to crack into that tool, because they know like how it's organized or whatever, then they can go and extract all that information and siphon it off and deliver it to wherever they are. And those are, again, things that people sell in large bulk quantities on the internet. Has a huge economy that wants to buy that stuff for lots of money. So again, people steal information like this. A lot of it's for financial gain. They aren't necessarily trying to impersonate you. They steal the information so that people who are very skilled at impersonating you can try and impersonate you. Or maybe, people who aren't but have a lot of money. So another function that I'll describe is called rootkit. And a lot of you have probably heard the term rootkit like thrown around. It's another one that, just like Trojan, that I think gets used a lot to mean a lot of different things depending on who's saying it and what the documentation is. But one of the big things about it that I'll describe here is that it uses the operating system interfaces to conceal evidence of the malware from someone inspecting the system. Sometimes in some malicious tools it'll be described as stealth mode. And the real goal here is, unlike the Trojan, which Trojan attempts to mislead you about what that program is, but doesn't actually take any mechanism to try and hide itself, this one actually will frequently get installed with super user privileges, which means like administrator or whatever. So think that fake driver download that I explained to you. So if you download that fake driver download and then you try and run it to install what you think is a new driver for your Intel wireless card, when it asks you if you want to grant it administrator privileges to install the whole thing, you're going to say yes, because that's what you expected it to ask you. Well, in this case, something like a rootkit will take advantage of that privilege grant, and it'll install drivers on your system that can then be used to cover up whenever you want to see your process list. Whenever you want to get a list of all the programs that are running on your system, like with the Task Manager in Windows or with Process Explorer, when one of those tools goes and asks Windows, give me a list of all the programs, that request will first go through your driver, and then your driver will go and get the list of all the programs, and then when your driver gets that list, your driver will walk through it and you'll say, oh, there's me. I'll remove myself from the list, and then I'll send the shortened list over to the application that originally asked for it, like Task Manager or Process Explorer or something like that. So likewise, when you're navigating the file system in Windows, you're probably familiar with that you can have those hidden in system files options in the folder, and a lot of times if you want to see all the files in a folder, you need to go into the options and change it so that you can actually see those things instead of hide them. So under the hood, there's a whole bunch of Windows API calls that are being made to go into those folders and then list the content of those folders. A driver that's written as a rootkit can actually replace that call with the driver's call, so with the rootkit call. that'll go through and it'll say, oh, is this a folder that I live in? If it is, then I'll make sure that the explorer.exe process that asked for the contents of this folder, it gets all the contents except for me, the malware file. And so then when you are a user trying to browse around your system, trying to make heads or tails of why it's slow, or why you keep getting these pop-ups, or why it just doesn't seem to be working right, or why your camera keeps coming on, or something like that, unless you actually physically remove your hard drive from your computer and then plug it into a forensic system or something like that that can go through and look at your hard drive without running your operating system and your programs and your drivers, that malicious intrusion will actually be hidden from you. So rootkit is really commonly used to try and be a really good way of concealing a malicious program on your system. So finally, virus and worm. These two are also two words that are used very commonly, very frequently. Everything's a virus is kind of the joke that we like to throw around when we're talking about security problems. But they actually have, they actually have very specific biological meanings, right? And because of that, their original use, what their original intent was in trying to describe computer cybersecurity problems, was using those words for very specific reasons. And so I'll go into the definitions that I plan on using here, which is basically both of them describe approaches to self-propagating malware. So if we're familiar with how viruses and worms work, and they're definitely not the only two organisms that behave this way, but they do both have the property in biology of being organisms that can self-propagate. So they replicate themselves typically in order to propagate. So worms, the way I usually describe those is when it implements worm functionality, it means the malware has the ability to replicate full copies of itself across the system and even over networks through various means. So a worm that also has a mailer component may email copies of itself to other people. Or it may look to see what network drives are connected, and it may make a copy of itself and write it into all the folders of any network drive or any USB drive that's plugged into the system. So generally, when it's trying to make full copies of itself across the system, across networks, whatever, I generally refer to that type of feature as a worm. It uses very simple file system calls to perform the propagation. Viruses, on the other hand, tend to take a more advanced route that also allows them to conceal, basically be very difficult to track down, but conceal their destination. And I've seen this a number of times too. It has the ability to insert its functional code into existing programs or files on your system. So we're all familiar with like exe files and stuff like that. We know that machine code lives in there somewhere. And actually, in many cases, you can walk through that machine code. We'll have some tools to do that later on that allow you to see what that functional structure is. If you're a virus, what you do is you try and use some of those techniques to identify where you could insert machine code such that that machine code gets executed by anything that wants to use that library or by any program. So for instance, if I installed a video game on my computer and that part of that video game got infected, we'll say infected by a virus, that means that the virus has actually taken some machine code that it has and it is overwritten or maybe appended to one of the programs or libraries that are part of that video game. Some machine code that implements whatever the end goal of the virus is. And some of them, like I think, I can't remember, some of the really early ones, their entire purpose was just propagation. It was demonstrating that that technique could be used for propagating itself and everything. More recently, I've seen a number of backdoors that use this mechanism to propagate, and therefore it becomes very difficult to identify them because they've managed to efficiently compact the code to create a bidirectional network communication into an extremely tiny, like 1 kilobyte chunk. And then they'll go and find a program or a library that they can overwrite with it. And basically when that library gets loaded, which it may get loaded through the normal running of Windows, it's kind of hit or miss as to whether that actually breaks anything or not. In some cases, that might not actually break anything, at least not visibly. Your computer may behave slightly differently, and a handful of things that you do on it might be a little bit more unstable. You might get a lot of like error dialog boxes and stuff like that, but hey, they bet on the fact that there's so much software out there that crashes without being infected by a virus, that being infected by a virus doesn't actually raise any red flags in your mind. So you may just have to click through a little bit more pop-up boxes throughout the day. So that said, that's the end of the lecture for today. I'm just glad I was able to get all the way through all these slides. But these are the terms that, kind of the ways that I like to describe it. And also, again, the reason I'm talking about this stuff is because when you are analyzing malware, one of the big goals is to try and describe what it does. That's usually what people want to know. So one of the things that we will do going forward in the class, when we get to malware analysis and everything, we'll start using some of the indicators that we're finding in malware and some of the techniques that we're using to try and see if we can answer these questions. What functionality does it do? What behavior does it do? What families is it a part of? That type of stuff.